Start recording. There we go. How did we know that the CaOH2 solution, and I'm going to start using the abbreviation SOLN for solution because it makes my life faster if I write it that way. How did we know that the CaOH2 solution was saturated? Have a chat with your neighbor about that.
I think there was still like calcium hydroxide and you could like see it. And it was like sitting at the bottom of the I think on birthday, yeah.
All right, friends, how did we know? Yes.
There was like still calcium hydroxide sitting at the bottom, which is like undissolved. So it's kind of like.
Yeah, and it wasn't like we just dumped it in and let it sit there either, right? What did we do with it? We dumped it in, and what did we do? We dumped the calcium hydroxide into the water, and what else did we do? We heated it. Heating usually increases solubility, the ability to dissolve. And what else did we do? We stirred it. And stirring usually increases the ability to dissolve. So we had some undissolved. What is the name of this compound? Tell your partner. Feel free to use your periodic table if you can't remember Ca. All right, someone give me the name of that compound. Calcium hydroxide. Ca is calcium. OH minus is hydroxide. You will have a table of common ions when we actually get into the naming section. Okay, so we did have some undissolved calcium hydroxide. And what does it mean if I put this S here? Solid. Remaining, even though, tell your partner what even though. I'm looking for someone who hasn't answered a question for me yet. We had some undissolved calcium hydroxide solid remaining, even though what happened? Even though we did what? We heated it. And what's the second thing we did? Stirred it. Yep. Very good. So if I was to ask you, how could you make a saturated solution? Tell your partner, how would you make a saturated solution?
Dump a lot of it in. So where were you for like 3 days? Oh, I thought you went on the station.
Wouldn't that have been nice?
Tell sickness is not like the flu.
Okay, how can I make a saturated solution?
Just gotta keep on dumping solute into it.
But you've already answered a question. But if someone heard him and wanted to reiterate that,
You're out of Ragnarok, bro.
I'm going to wait until somebody decides to answer my question. It can't be someone who's talked to me already. Yes. Yeah, you're going to keep on adding the solute to the solvent. So we're going to keep on adding the solute to the solvent. And we're not always going to heat it. Heating isn't necessary all the time. But what should we be doing? Stirring and stirring. Until, tell your partner what? Until what? What the hell is in there? Is there zinc in there? Oh, that's weird. Oh well. All right. Until what? We add solute and we stir until it stops dissolving, until some solid, some undissolved solid remains. And then if you want to, you can filter out the undissolved solute, okay? Then that's my T, that's the letter T. If you haven't picked up on that yet, that's because they used to teach cursive back when I was in school, okay? Then you can filter it if you want a clear solution without any solid suspended. Okay, how are we doing here? We're doing okay. All right. Okay, so we have the maximum amount of dissolved solute. So do you guys know what kind of a compound is calcium hydroxide? Chat with your neighbor about that. All right, ladies and gentlemen, what kind of compound is calcium hydroxide? Ionic. And because it is ion, it is made of what? Metal and non-metal, but I want to be more generic. Ionic compounds are made of ions. What do we call the positive ion? Cation. And what do we call the negative ion? The anion. And who is the cation in calcium hydroxide?
Calcium.
Calcium, Ca2+. And what is the anion in calcium hydroxide? What's the anion?
OH minus.
OH minus, yes, hydroxide. Okay. So, can you see why we need the 2 in the formula of calcium hydroxide? Why do we need the 2 in the formula of calcium hydroxide?
What happens if I don't balance it? What does it do? Blow up?
Yes, pretty much.
Oh, really?
Yeah. Answer that to your partner. Why do we need the 2 in CaOH2?
Just know that. Not an idea. I always like leave that regular left hand, right hand maybe. Yeah. I don't know. Watching my TV show, right? I felt like these people in a jungle. Apparently, nitrogen was broke up. It's in dynamite. Lost. Almost season 3. Where'd you work? Disney Plus.
Why do we need that 2? Ah, I see people crisscrossing. This will work, but that's not why we need it. That's a trick to allow you to find formulas quickly. So if you have Ca2+ and OH, which is minus, which means minus how much? Minus 1. If you crisscross these numbers, that will indeed get you the formula, okay? Which will mean that we have a Ca1 and then we have OH2. What's wrong with that formula? There's 2 things wrong with that formula the way I've written it right here. I don't need a subscript for calcium. Okay, we don't write the subscript 1. Do not write the subscript 1. We just leave it blank. There's something else that is wrong. Yes? Exactly. Right now, that means we have 2 hydrogens, but only 1 oxygen. Okay, so it applies only to the H, not the O, therefore we need brackets. All right, so our formula then would be Ca Whoops. OH. 2. What's wrong with my formula the way I've written it now? Yes. I need a capital C. I didn't actually mean to write a lowercase c, it just came out small. But yeah, if yours comes out small, you need to make it big. Okay? So this one is wrong, this one is correct. All right. So where were we going with this? So we have an ionic compound, so it's made of ions. And do you remember what structure an ionic compound makes? Tell your partner, what structure does an ionic compound make?
What structure? What structure does it make?
You can draw a little picture for your friend and maybe they'll remember the name.
I'm pretty here, bro. Before you went away. You got answers. You're finishing your hand. We're trying to get to number 7. I mean, we're trying to get to number 6. We're not getting them.
All right, you can either tell me the name of the structure or you can describe the structure to me. A crystal lattice. And I would like you to describe to your partner, if you have not already done so, what a crystal lattice would look like. Or you can draw it if describing is too difficult. By the way, this is review for your test on Thursday. All of this. Well, except for writing the formulas, you don't have to do that. All right, what does a crystal lattice look like?
Like a square.
Like a square, but what's in the square? Alternating positive and negative ions. Now, to be fair, because we have a 2-to-1 ratio, the crystal would look really complicated. So we are going to simplify it down to a 1-to-1 ratio, just because drawing a 2-to-1 crystal is really hard. Okay, so we're not going to draw a 2-to-1 crystal, we're going to draw a 1-to-1 crystal because it just makes our life simpler. So it would look like this: positive, negative, positive, negative, negative, positive, negative, positive. And I'll do one more row so it actually looks kind of square-like. Positive, negative, positive, negative. That's a good question. Why are the negatives so big? Very good question. What do in order to become negative ions, what do atoms do?
Oh, yeah, what do they do? Yep, a little bit like that.
Yes. If they lose what charge are electrons? Yeah, they need to gain electrons. Because electrons are negative. If you gain electrons, you gain a negative charge. Now, what do electrons do to other electrons? Electrons repel electrons. And if they're repelling each other, what's going to happen to the size of the atom? As we go from atom to ion, we're going to get bigger because there's more repulsion. More electron repulsion. So it gets, the anion is bigger. We're going to learn all of chemistry 11 just today, just by doing this lab. Now, I'm going to put a bracket around this because this is not going to be on Thursday's test. However, it is useful for you to know because it will be part of Unit 3. Okay? Unit 2, we're going to do some more math and some more particles. Okay? I realized, and don't worry, I'll print this out for you. Okay? I realized that we never did answer why we need the 2 in CaOH2. Compounds must be what charge? Overall. Neutral. Therefore, the positive must equal the negative. So if you have a 2 positive, you also need to have a 2 negative. Okay? All right, what structure does an ionic compound make? It makes crystal lattice. In order to become a negative ion, a neutral atom must gain electrons. Now, why is that positive ion so small? What does, in order to become a positive ion, a neutral atom must do what? Chat with your neighbor about that. In order to become a negative ion, a neutral atom had to gain electrons. Because gaining electrons have a negative charge, that made it negative. What do we do to become a positive ion?
Lose electrons.
Yeah?
Oh my god, that's why they're so small.
What do they have to do? They have to lose electrons. Okay? Now, this is even fancier. Watch this. I'm going to draw you a Bohr model. Okay? We're going to do a Bohr model of calcium. Ca atom, Bohr model. Okay, so what row is calcium in? Take a look on either that periodic table or this one, or if you have your own, you can look there. I'll hit the lights just for a second so you can see a bit better. What row is calcium in? It's in the second column. Tell your partner. Take a look up there, take a look up there. I gave you guys a periodic table. Feel free to bring it out. Put up the number of fingers of the row it's in. It is in row 4. And if you're not finding it, it is, calcium is right here. I know that the room is really big, so if you're not sitting in the right place, it's sometimes hard to see. So calcium is right here in row 4. So if calcium is in row 4, how many occupied electron shells does it have? Just in case you're wondering, this is kind of how I teach my enriched class. We just sort of go crazy. So we're going crazy today. We're reviewing everything from grade 9 and 10 today. Plus we're adding on to it a little bit. Well, let's think about hydrogen. Think about hydrogen. How many electrons in a hydrogen atom? Do you guys need a periodic table? What you're going to do, you're going to come up here and you're going to borrow one of these if you don't have yours, and then you're going to return it when you're done. So if you don't have your own periodic table, come and grab one from here and then return it when you're done. I'll get at the end of class. Where did my... Oy vey. What happened? Wow. Oh, ow. Okay. Sorry, I'm having a little panic attack here because I've lost my... Oh, there we go. Okay. Here we are. Please come and help yourself if you can't find yours.
No, I'll get one.
If you do not have a periodic table in front of you, then you will not be prepared to do this. Get your periodic table in front of you. Borrow one from me if you need to. Okay, I want you to look at hydrogen, please. How many electrons in a hydrogen atom? In a hydrogen atom. Actually, you know what? I'm going to change it to protons to start with. How many protons in a hydrogen atom? I want you to look at your periodic table. How many? Is it 2 or is it 1?
1.
There's 1 proton. Remember, what is this number here? This is the what number? Atomic number. And what does it equal? The number of protons. Okay? So we have 1 proton. How many electrons? How many electrons in an H atom? 1. How do we know that? Atoms are what charge? Tell your partner, what charge are atoms? Atoms are neutral, which means that if you have 1 positive particle, you must have 1 negative particle. So hydrogen has 1 electron. So let's draw a Bohr model for hydrogen. Here's its nucleus. There's its first shell, and there is its electron. That's a hydrogen atom. How about a helium atom? How many electrons in a helium atom? Tell your partner how many electrons in a helium atom.
How do you think? God, you're panic? Big panic, like really? Oh, you like what? Oh, mucho capacity.
How many protons? 2. How did you know that? Because the atomic number is 2. And that means our electrons have to be 2, because these 2 are equal to each other. Yes? So if I draw a helium atom, I've got my nucleus. I'm not going to draw all the protons. I'm just going to put plus in the center and not going to tell you how many. How many electrons should I have and where should they go? Do I need another shell yet? No. They should be paired up. If you didn't draw them paired up last year, that's okay. We're not actually going to draw Bohr models very often this year because they are kind of awkward and stupid. Okay? They are a good model for showing certain things like bonding, but they are a poor model in that they don't show the reality. And if you're just showing bonding, you can use Lewis structures, which are way more streamlined and easy to deal with. Okay, but we're familiar with these from grade 9 and 10, so we're going to use them a little bit this year. So what row is hydrogen in? Hydrogen is in row what? 1. Helium is in row
18.
No, it's in column 18. Rows go this way. What row is helium in?
1.
1. We're going to do one more. Lithium. How many protons in lithium? How many protons? 3. How many electrons? 3. Okay. One, 2 electrons. Do I need to draw a new shell? Yes. Because my third one has to go here. What are the maximum electrons at each level? Max number of electrons in each shell. Shell 1. How many? 2. Shell 2. 8. Shell 3. 8. And after shell 3, the model falls apart. You will see people, drawing Bohr models for elements past calcium, but you really, it's not meaningful particularly, and it's not useful particularly, so we're just going to ignore that and just say it falls apart. But we can put a couple of electrons into shell 4. I mean, technically you could say shell 4 has 18, but we're not going to put more than 2 in there. All right, so what row is lithium in? Lithium is in row 2. So remember, hydrogen, stupid erasing pen thing. Hydrogen is in row 1. Helium is in row 1. Lithium is in row 2. What does the row number tell you? The row number tells you the number of occupied electron shells. So if you're in row 2, you have 2 occupied electron shells. So the row number tells us the number of occupied electron shells. So if calcium is in row 4, how many occupied electron shells does it have? 4. So what we can do is for calcium, we can say, here's my calcium Bohr model. Here's my nucleus. And I'm going to have 1, 2, 3, 4 shells. Yes? Now, how many electrons does calcium have? Calcium, atomic number 20, therefore it has 20 electrons. Now let's see if we actually end up with 4 shells worth. Here's number 1, here's number 2. Do you remember how to put the electrons into the second shell? Or you may have learned it differently, but I'm going to show you how, okay? And then we're going to take a 5-minute break. So pay attention for the next 5 minutes, and then we can have a break, okay? Yes? Yes? Okay, here we go. 1. Second one goes, so we go top, right, bottom, left, like we're going around a clock. Okay, so top, right, bottom, left. Now we have 1, 2, 3, 4, 5, 6 electrons. Where are we going to put the 7th electron? Top. And then we go to the right, and then we go to the bottom, and then we go to the left. All right, and that gives us how many electrons? 10. Okay. Oh, I've only drawn 1, 2, 3 shells. I need to draw a 4th shell. Oopsie. Here's my 4th shell. Okay. Maybe I need to get rid of that. There we go. Okay, calcium atom. And then I'll have... Who puts the eraser right where you hold the pen? That's what I want to know. Now we have 8 plus 8 plus 2 is 18. And then we have 19, and then we have 20. All right. And do you notice how many occupied shells did we end up with? 4. And how do we know that we have 4 occupied shells without drawing it all out? The row tells us the number of occupied shells. Okay, so let's look at this calcium atom. And what does it need to do? It needs to lose electrons. How many electrons would it need to lose to become a calcium ion?
2.
It loses 2 electrons. Ca 2 plus. And I'm going to make this small now. Okay, so you can see both at the same time. Now I'm going to redraw we had a calcium atom. Now we're going to have a calcium ion. And what do you notice about the size? The size is smaller. Why? Because we have fewer occupied electron shells. Cations are smaller than neutral ions because we have fewer occupied electron shells. And we are going to take a 5-minute break until 11:30. Okay, and then we're going to come back and we're going to finish this up. Okay? We may or may not finish actually today. We might have to finish tomorrow.
Are we gonna do 6 and 7?
We'll get there. We'll get there.
Alright. Oh, my freestyle finally.
I just thought we might as well burn all of Chem 11 while we're at it, right? Or at least units 3 and 4. Don't be late getting back.